So hello guys and welcome to the very next tutorial of data structures using Python. So in the previous video we discussed about linked list, why we need linked list and how it is different from array. Now in this video we will just learn to implement it, some basic functions of it, like inserting from beginning, inserting from end, and also we will see the running complexities of these functions. So let's just begin. So first we need to create a package named as linked list. This package will basically contain all the requirements for the linked list data structure, all the files, all the Python files that are needed to run the linked list or implement the linked list data structure. Now the two things that I want to say to you guys is I'm going to use the Atom editor. You can even work on Notepad or whatever editor you want. And second thing is that if you haven't watched the previous video, you must watch it because that will help you to understand the linked list codebook better. So just let's start. Atom editor. Now just save it on desktop in the linked list folder, and the name will be node.py. So let's create a class node. Now a node is made up of two things. First is data part and second is pointer part. So let's make an init function. And guys, if you don't know the OOPS concept, like what is init function and what is self and why we wrote object here in the class node, then you need to watch my Python tutorial series where I have discussed every OOPS concept. So just self and data, self dot data equal to data, and self dot next equal to none. So what is happening here? Okay, we are actually creating a node like this by using the init method, and we are putting the data here, and this is the next pointer actually, and it is presently pointing to nothing, so none. I hope it is clear now. So whenever I will create a node object, it will directly call the init method. Init is nothing but initialization method, or you can say a constructor in C++ and Java. So it will directly call init method, and in the init method we are initializing the data and we are initializing the pointer. Let's save it. Now let's make the second file, which is save as linked list.py. So this Python file will contain all the functions of the linked list, like insertion of a node, deletion of a node, traversing, etc. So let's begin. Class linked list object, and the first function is going to be init function. So for example, the node needs data and next pointer for initialization. What the linked list needs, the first thing that needs to be initialized in linked list is the head. So let's create a head variable, self.head equal to none. The thing to note here is, why didn't I create head like this, head equal to none, and why I am creating self.head equal to none? The reason behind this is, when we put self against self in front of a variable, any variable in Python, it becomes a global variable. It means that it can be accessed by any method present in the linked list class. So if I make a function here like definition add node front, so even this add node front can access the head method. So for adding a node in front of the linked list, we need to create a node, and to create a node we need to call the node class init function, and its requirements are data. So we will take data as our input, data as our argument in the function basically, and now we'll create a node which is new node equal to node.node data. Now a thing to be noted here is, guys, that we are creating a new node, okay, but why are we writing like this, node.node.data? The reason is, first we are saying that, hey Python, access the node.py file. By this node we are saying go to the node.py file, go inside it. So when I write node, I go inside the node.py file. Now we will check how many classes are there or how many methods are there. So we see there is only one class, that is node class. So we need to access that for initialization of the node. So we will write node.node. This node is basically representing the class node present in node.py file. So we will just initialize data that is given as input by the user and set its pointer as none. So a new node is created now. So what next? Now there will be two cases while adding a node in front of a linked list. The two cases can be, presently there is no element in the linked list, so the front element is going to be our new head. Congratulations to that, and that is the easy case. And the second case, already nodes present in the linked list. So let's see the first case when there are no elements in the linked list. If self.head is equal to none. If there is no element in the head, okay, if the head is created but there is no element in it, then we are going to give element to the head by giving the new node to it. So we created a node, and after that if self.head is equal to none, self.head equal to new node. Else, if there are elements present in the linked list. So what we need to do in that case, if there are already elements in the linked list, then we will make the new node as our head. So just new node dot next equal to self dot head, and self dot head equals to new node. Now we need to add from the end, so we will write like this: add node end, and while adding the node at end we still require the data. So similarly we will create a new node, node.node.data. If there is no head, then the node we are trying to insert at end is going to be our new head, and else we need to traverse the linked list to the end node, and then we will insert the new node. Okay, so for traversing we require a temporary node. Let's create a temporary node, temporary variable, temporary node. This temporary node will have self.head. As I said in the previous video that you can only access head, you cannot access directly the last variable. So I access the first element, which is head. So now temporary node is holding the variable, holding the value of head, and we'll use a while loop while we don't reach to the last element. What is the speciality about the last element of linked list? The last element pointer is null. So while temp node dot next is not equal to null, is or not equal to none basically in Python. While temp node dot next is not equal to none, we need to jump. We need to go to the next node, then to the next node, then to the next node. So temp node equal to temp node dot next, and as soon we will find it as null, we will set next as new node, and our head is still the same. So this is the addition of node from the end. So I will just explain it to you by using paint. Suppose we want to insert 12, 13 and 15, 12, 13, 12 and 13 from front and 15 from end. Front and 15 from end. Now let's start. So let's add 12. So a new node will be created for a new node will be created for adding 12, right? By this new node.data. So this new node is created, which contains 12, and this points to null by using the node.py file. Okay, now what? Now if self.head equal to none, is head none? Yeah, basically when the linked list object is created, when the linked list object will be created, initially the head is none. So head is actually none. So we will just see if self.head is equal to none, then self.head equal to new node. So this will become our head now. So just rub it, new node, just rub this new node, and now this is our head. Okay, now lesson the 13 in the front. Now let's create again a new node will be created. Suppose this is the new node 13, and again this will be null, pointing to null, not pointing to anything, right? If self.head is equal to no, self.head is not none, it is 12 presently. So we'll go to the else case. Else case says new node.next equal to self.head, right? New node.next, new node next pointer, new node next pointer means this thing which is pointing to null will now point to the head. So we'll just rub null, we'll also rub this pointer, and we will make it point to this, and self.head equal to new node, and make this new node as my head. So we will rub head and we will make this new node as our new head. Here it is. What is the last thing we need to do? We need to insert 15 at the end of the linked list. So we will go to the add node end function, right? So first a new node will be created. So let's create a new node here. It will hold the value of 15 as data, and this will point to null, right? Or cross, null or cross. You can represent null by cross. I'm representing by null as lack of spaces here. So a new node is created. Then if self.head is equal to none, is head none? No, head is actually 13 this time. So we will go to the else case and we'll store the head in the temporary variable. So temporary node, let me rub this. So yeah, we were inserting 15 at the end, right? So let's create a temp node like this. Now this temp node is same as head now, because as it is written in else case, temp node equal to self.head. So this temp node is same as head now. So it will be also pointing here like this. This is actually temp node. Temp node, right? While temp node.next is not equal to none. Let's see if what is temp node.next not equal to none. Actually we are traversing to the last element, right? So let's see. Actually temp node.next is 12 and it is not null. So this while condition is true. So what is the while condition inside it? What is written? This temp node equal to temp node.next. So our temp node will become now 12. Now this will become our 12 temp node. So just rub it, and this is our new temp node. Temp node. Now let's again check. What is while temp node.next is not equal to none. What is after that? What is temp node.next? Yeah, temp node.next is now null. After 12, the pointer to 12 is pointing to null, as it is written here. So we will get out of the while condition, while loop, and just temp node.next and set it as new node. So the next here, this pointer, this null will go away, and it will now point to 15. So this is our new linked list created, in which 13 and 12 were inserted from the beginning and 15 was inserted from the end. I hope it is clear.